Okay, so now we're going to solve percent applications. Okay, so what I want you to remember on this page is the word is. Whenever you see the word is, let me use a different color here. The word is means equals. The word of means multiply. Alright, so whenever you read those words, that's what you should fill in for those places. So what number stands for X? Is means equals. You always want to turn your percents into decimals, otherwise you're going to get the wrong answer. Of means multiply. I'm going to use parentheses here. 90. Okay, so we have written this, we have translated it into algebra. Now to solve this, we want to multiply by 0.35 times 90. And you get that X is equal to 31.5. Now ask yourself, does that number make sense? 35%, approximately a third, not quite a third, but approximately a third of 90 is 31.5. Does that number make sense? You always want to make sure that it does. Okay, if it sounds about right, you're in good shape. So always ask yourself that question whenever you're finished with one of these problems. Okay, so on this problem, we're also going to translate and solve. So 6.5% written as a decimal. Remember, scoot it to the left 2 places. Of means multiply. What number means X? Is means equals, and notice how this says $1.17. That implies that we're dealing with money. So we've got 0.065x is equal to $1.17, and I want to divide both sides by 0.065. And so I get that x is equal to $1.17 divided by 0.065 is 18. 18 what though? Remember, we're dealing with money here, so $18. So 6.5% of $18 is $1.17. Alright, so let's look at this one. We're going to translate and solve this. 144 is means equals. What percent means X? Of means multiply. So we actually have something that looks a little bit cleaner whenever you write it like that. So we're going to divide both sides by 96. So 144 divided by 96 is 1.5. Now, am I finished with this? Is my answer 1.5%? No, I got the decimal version. I need to turn this into a percent. So that is equal to 150%. And we knew that it was going to be more than 100 because 144 is more than 96. So I knew that it had to be more than 100. Okay, every time we do word problems, I always show you a page that looks similar to this. And I'm pretty serious about you reading the problem. You've got to read your problems very carefully. And if you don't, then you're going to rush into doing things the wrong way. Remember, practice doesn't make perfect. Perfect practice makes perfect. So you have to practice correctly or you're going to be practicing wrong, and those are the mistakes you're going to make on the test too. Dazan and his girlfriend enjoyed a nice dinner at a restaurant, and his bill was $68.50. He wants to leave an 18% tip. If the tip will be 18% of the total bill, how much tip should he leave? So we've got 68.5 or 68.50 times, and remember, turn this into a decimal, 0.18 is the amount of tip. So on my calculator, 68.5 times 0.18, and I get $12.33 is the amount of the tip. Okay, so on this problem, the label on Maceo's breakfast cereal said that 1 serving of cereal provides 85 milligrams of potassium, which is 2% of the recommended daily amount. what is the total recommended daily amount of potassium? All right, so we're going to let X equal total recommended amount of potassium. All right, and I know that 0.02, which is 2% as a decimal, times X is 85 milligrams. So now I'm going to divide both sides by 0.02. So I've got 85 divided by 0.02, and I get my total recommended amount is 4,250 milligrams of potassium. Alright, so in this problem here, Mitzi received some gourmet brownies as a gift. The wrapper said each brownie was 480 calories and had 240 calories of fat. What percent of the total calories in each brownie comes from fat? And so we are going to let X equal the percent of fat. Now, because we wrote that word percent, that likely means that we're going to have to scoot the decimal to the right 2 places to get it in percent form. All right, so it says here, what percent of 480 is 240? That's what this question really says, okay? So, X times 480 is 240. Divide both sides by 480, and I get that X is equal to 0.5. But don't forget, we're looking for percent here, so I've got to scoot that over 2 decimal places. So 50%. All right, so now we're going to look at increase and decrease. So to find the percent of increase and decrease, you would do the, let's see here, new amount minus the old amount, and you want to always divide by the old amount. Whatever number you get here, then move decimal. Uh-oh, I can't write. To the right 2 places. Sorry, I'm being sloppy. Okay. So now, remember, new amount minus your old amount, divide by your old amount, then move your decimal. All right, so let's look at the next one. Okay, so it says in 2011, the California governor proposed raising community college fees from $26 a unit to $36 a unit. Find the percent of increase, round to the nearest tenth. So we want, remember, new minus old divided by old, okay? So it went from here, there's your old, to here, so there's your new. So I've got 36 minus 26 divided by 26. And then I want to move my decimal to the right. So 36 minus 26 is 10 divided by 26, and I get this big long number. Look what I get. So I get this. I'm going to write down all the numbers. All right, so that's the decimal that I get. 0.384615385. Okay, so now I want to round to the nearest tenth of a percent. That means first I've got to move my decimal 2 places. Right there is where it's going to end up. And I want to look at this number right here. If it's 5 or greater, round this guy up. If it's 4 or less, just drop everything. So this would end up being 38.5% increase. By the way, if it's a positive number, it's an increase. If it's a negative number, it's a decrease. The average price of a gallon of gas in one city in June 2014 was $3.71. The average price in that city in July was $3.64. Find the percent of decrease. All right, so again, you want new minus old divided by old. So our new price was this. So that's our most recent price. What am I doing here? Minus my old price. There's my old price right there, 3.71, and always divide by 3.71. I want you to be uber careful about how you type this into your calculator. If you type this whole thing into your calculator and you don't use any parentheses, you will miss this problem. You have to put parentheses around the numerator if you're going to type the whole thing in all at once. If you don't, your answer here will be 2.64 because 3.71 divided by 3.71 is 1. And 3.64 minus 1 is 2.64. So that's why you have to use your parentheses. It tells the order of operations that, hey, we want to subtract this numerator first, and then we're going to divide. All right, so 3.64 minus 3.71 divided by 3.71. And I get this. I'm going to go ahead and just write everything down. 18867,925. Okay, so now let's give this to a tenth of a percent. So again, you got to move your decimal to the right 2 places. So I get 1 point, and because this is an 8, I'm going to round this up. And don't forget, it's a decrease, so we're going to have negative here. So it's a decrease of 1.9%. Okay, so let's talk about simple interest again. So it is really important that you understand the difference between interest and principal. And know that your rate needs to be as a decimal. And your time is always in years. Okay, so typically the interest will say the word interest around it. They earned this much interest, or they paid this much in interest. And principal is typically either the amount that you put into an account to earn money or the amount that you borrow from a bank. Okay, so on this one, Nathalie deposited $12,500 in her bank account where it will earn 4% interest. How much will she earn in 5 years? Okay, so again, I'm going to fill in what I know. I always write these down. Every single time, no matter how many times I do a simple interest, I always write I, P, R, and T. And I'm always going to use this for simple interest. Interest is equal to principal times rate times time. So this right here is principal. That's how much she deposited. 4%, there's my rate, and 5 years, there's my time. So I don't know the interest. I'm just going to put an I in for interest. 12,500 is going to go in for P. My rate, don't forget, that's as a decimal, so 0.04, and the time is 5. So using this formula, I don't know. P is 12,500. R is 0.04, and T is 5. So now just on my calculator, I'm going to type in 12,500 times 0.04 times 5. And I get that the interest is $2,500. And that number makes sense. Now, if you were to use 4 for 4% rather than turning that into a decimal, you would get an answer of $250,000. Think about whether or not that makes sense. Do you really think that in 5 years, $12,500 can turn into $250,000 at a bank? Ask yourself if the number makes sense, okay? And if it doesn't, then maybe go straight to that rate. You probably put your decimal in the wrong spot. All right, on this problem, Lauren loaned his brother $3,000 to help him buy a car. In 4 years, his brother paid him back the $3,000 plus $660 in interest. What was the interest rate? All right, so that's what we're looking for. This right here is the principal amount. That's how much he loaned him. 4 years is our time. Interest, oops, that's an I. So the 660 is our I. So Remember, I told you I do this every single time, and I'm serious, I do. So the interest is 660. The P is 3,000. The R is what we don't know, so I'm just going to call it R. And our time is 4 years. So again, I'm still using this formula. And I'm just going to put in everything I know. So I do know that this time, so I'm going to put 660 right there. The P is 3,000. The R is something we don't know. And the T is 4. And now I'm going to divide both sides by 12,000. So I've got 660 divided by 12,000, and I get this number. Don't forget, I have to turn this into a percent. So this is going to be equal to 5.5%. That's the interest rate that his brother charged him, 5.5%. Okay, so here we are again. Eduardo noticed that his new car loan paper stated that with a 7.5% interest rate, he would pay $6,596.25 in interest over 5 years. So the question is, how much did he borrow? So we're looking for the principal amount here. All right, so the interest is $6,596.25. The P, we don't know that. The rate, don't forget to write that down as a decimal. And the time is 5 years. So I am still using the same formula, I equals P times R times T. And I'm just putting in what I know. 6,596.25 is equal to P times R times T. On my calculator, 0.075 times 5, and I get 0.375. Now I'm going to divide both sides by 0.375. And I get $17,590 is how much he borrowed. So his principal amount is $17,590. Okay, so now we've got amount of discount is equal to the discount rate times the original price, and then the sale price is your original price minus the amount of your discount. Markup goes in the same way. This is if you were if you owned a company and you sold things, you would need to mark up the items so that you could make a profit, so that you could live and eat. And so amount of markup is equal to your markup rate times the original cost, and then your list price, how much you're selling it for, that's your list price, is your original cost plus the amount of your markup. So the only difference between markup and discount is on markup, you're adding. On discount, you're subtracting. Elise bought a dress that was discounted 35% off of the original price of $140. What was the amount of discount? So again, we're going to do 140 times the percent off, and that is our amount of discount. So 140 times 0.35 is $49. So there is a $49 discount on this dress. And the sale price of the dress is the original amount minus 49, which is 91. So she pays $91 for this dress. Jeanette bought a swimsuit at a sale price of $13.95. The original price of the swimsuit was $31. Find the amount of the discount. Well, the original was $31 minus the sale price, and that gives us the amount of the discount, which was $17 and a nickel, $17.05. Now, if you want to know your discount rate, you take the amount of the discount and you divide by the original amount. but as a decimal, this is 55%. So that swimsuit was discounted 55%. Adam's art gallery bought a photograph at an original cost of $250. Adam marked the price up 40%. Find the amount of the markup. So 250 times 40%, which is 0.4 as a decimal, is $100. So that's how much he's marking up this photograph. And so now to find the list price, you take the original price and you add the markup amount. So he is going to list this photograph for a price of $350. All right, that's it for this section. So if you have any questions, send me a message.